Good morning, my dear student in grade 5. We make a revision about what doesn't studied in grade 4 and second term. First lesson we doesn't study it is congruence. What's the meaning of congruence? First we have to figure A, B, C, D and figure X, Y, Z, M. If we cut this figure and put it on another figure, when we put vertex A up to X and vertex B up to Y and so on, we notice that we can see only one figure. Then you become sure that the two figures are congruent. What's the meaning of congruent? Congruent means the two figures are the same. We have corresponding side like AB, side AB, and the corresponding X, Y. These two sides equal in length, so we can set AB congruent to X, Y. And we have BC and YZ equal in length, so we can set the two corresponding sides are congruent. So if we find the corresponding side in two figures are congruent and corresponding angle like angle A and angle X that's corresponding equal in measure, that means the two figures are congruent. So what's the meaning of congruent? The two polygons are congruent if I found the two conditions. First, their corresponding sides are equal in length. So the sides are equal in length like AB and XY, and like BC and YZ, and CD and ZM. All the sides equal in length. So the corresponding sides are equal in length and their corresponding angles are equal in measure, like angle A congruent to angle X and angle B congruent to angle Y, angle C congruent to angle Z, and so on. We denoted the congruent by this symbol. We put three line, that means its read is congruent to. So we read this angle A congruent to angle X, angle B congruent to angle Y, angle C congruent to angle Z, and we can put measure angle A congruent to measure angle X. That's wrong. So if we put congruent, we can put measure. If we put measure, we can put equal. Measure angle A equal measure angle X. And also line segment, when we put line segment, we put congruent. We can't put equal. That's wrong. So line segment AB congruent line segment X, Y, and line segment BC congruent to line segment YZ. And we can put A, B, only A, B equal X, Y. If we put line segment, that means we put congruent. So the two polygons are congruent if their corresponding sides are equal in length and corresponding angle equal in measure. We have some special case like square. We know that the all angle in square equal in length, each angle equal 90 degree. All square in this world, its angle equal 90 degree. So we can say that all square, all corresponding sides in any square are equal in measure. So enough if we said the square, we must have only side. All square we draw in it, its side 4 centimeter, all of it are congruent. And if we draw square, side length equal 7 centimeter, all of them are equal because all corresponding sides are equal in length and all corresponding angle equal in measure. So it's that enough, only one side in square. And in rectangle, we must congruent in length and width. So if we draw rectangle, length equal 5 and width equal 3, and draw another rectangle, length equal 5 and width equal 3. We notice that two rectangles are congruent because we find the corresponding side equal in length and corresponding angle equal in measure. So enough for me, know the length in the first equal the length in other polygon, in other rectangle, and width equal the width in other rectangle. So it will be the two rectangle equal in length. So in rectangle we enough length and width. And in a triangle, all sides, if we find triangle, we draw triangle, sides equal 3 and 4 and 5, and we draw another triangle, the sides equal 3 and 4 and 5 also. That's two triangles are congruent. So the sides, the corresponding sides are equal enough to the two triangles are congruent. Then another lesson number 2, symmetrical figure and line of symmetry. What's the meaning of line of symmetry? Line of symmetry like line x, straight line x, y. Straight line x, y represent line of symmetry of figure A, B, C, D. Because if we folded this figure around x, y, the right part congruent with the left part. In this case, the figure A, B, C, D is a symmetrical figure around this line. So we can set that x, y line of symmetry. So line of symmetry divide the figure into equal parts, into congruent parts, and we can fold this figure around the line of symmetry. So we have two conditions. First, divide the figure the two congruent parts, and we can fold this figure around the line of symmetry. If we notice that the rectangle, we can put line of symmetry here, so we can divide the rectangle from here to equal parts, and we can fold this figure around this line of symmetry. We can put this point up this point, and we can fold it. So this line, straight line, called line of symmetry. And we can divide it from this sides, and we can fold it around this line. So this line also called line of symmetry. So the rectangle symmetrical figure and have two line of symmetry. But here, if we divide parallelogram from this part, and if we fold this point become here, so we can't fold the figure around this line. So parallelogram hasn't any line of symmetry, or has zero line of symmetry. So some figure has zero line of symmetry, and some figure has one line of symmetry, and some figure more than one line of symmetry. First, we start from triangle. We have three types of triangle. Equilateral triangle according to side. We have collateral triangle, isosceles triangle, scalene triangle. Equilateral triangle means all sides are equal. Isosceles triangle means only two sides are equal. Scalene triangle, all sides are different. So in equilateral triangle, we have three lines of symmetry. We can draw line of symmetry from this point, and we can draw line of symmetry from this point, and we can draw line of symmetry from this point. So we have three lines of symmetry in equilateral triangle. In isosceles triangle, we have only one line of symmetry. In scalene triangle, we have zero line of symmetry. Then quadrilateral, we have square and rectangle and rhombus and trapezium. In square, we have four lines of symmetry. In rectangle, we have two lines of symmetry. In rhombus, we have two lines of symmetry. In trapezium, we have zero line of symmetry, but the isosceles trapezium has one line of symmetry. In circle, we have infinite number line of symmetry. So in parallelogram, we have zero line of symmetry. We divide the parallelogram into congruent figure, but we can't fold the figure around this line, so we can set that AC, the line of straight line AC, the line of symmetry. So the parallelogram has no line of symmetry. In rhombus, we can divide the figure into parts, two congruent parts, and we can fold it. We can put angle D up on point B, so we can fold this figure around straight line AC. So straight line AC we can set straight line AC as line of symmetry. And we can also divide it into congruent parts like that. From this part, we can divide the rhombus, the two congruent figure, and we can fold it. So we can set straight line CD, line of symmetry of the rhombus. So the rhombus has two line symmetry. In trapezium, we have, if we divide the figure in isosceles trapezium, if we divide it to congruent part, and here we can fold it around straight line MN. But if we divide it from straight line EF, that's now we have two part not congruent part, so we can set that straight line EF, the line of symmetry. So the isosceles trapezium has only line of symmetry from this part. So isosceles trapezium has one line of symmetry, but the only trapezium has no line of symmetry, and so on. So we can solve that. Here we have isosceles trapezium because two sides are equal, so isosceles trapezium has one side, one line of symmetry, one axis of symmetry, And here we have isosceles triangle. Also, isosceles triangle has one line of symmetry, but trapezium has zero line of symmetry, and the parallelogram has zero line of symmetry. In rectangle, we have two lines of symmetry. In square, four line of symmetry. And if we have rhombus, in rhombus we have two axes of symmetry. So now we know the congruence and axis of symmetry. The third lesson, visual pattern. We know that before. We first discover the pattern, then complete by the same. Here, example number 1, we have A, B, C, A, B, C, A, B, C. So the pattern A, B, C. Repeat A, B, C. So complete by the same A, B, C, A, B, C, and so on. So the pattern sequence is A, B, C. Here, triangle look at up and triangle look at down, up and down, up and down. So triangle look at up and triangle look at down, and triangle look at up and triangle look at down, and so on. So the sequence is triangle look at up and triangle look at down, and so on. Here we have 2 bar and 3 bar and 4 bar, and again we have 2 bar, 3 bar, 4 bar. So draw 2 bar, then draw 3 bar and sequence, 2 part and 3 part and 4 part and so on. So first discover the pattern and complete by the same pattern. 100, 90, 80, so 70 we decrease by 10, 70, 60, 50 and so on. So the pattern sequence is negative 10. We subtract 10 and so on. So first discover the pattern, then complete by the same. Here in number C, 13.2, 13.4, 13.6. So we add 0.2. We add 2 tenths. So now we have 13.8. And if we add 2 tenths, that means 2 plus 8 equal 10. 0 carry up 1. Put the decimal point. And 14. So 14.0, 14.2, 14.4 and so on. So first discover the pattern, then complete by the same pattern. Increase or decrease and so on. Thank you.